Let's discuss about physical properties of carbonyl compounds, that means aldehydes and ketones. There are very, very important two properties, physical properties of aldehydes and ketones. First one is they are highly volatile liquids. They evaporate very, very fast. They are highly volatile liquids. And then they are highly water soluble. They are volatile. They are highly water soluble. If you hear somewhere a compound is highly volatile liquids, the meaning is it has very, very weak attractive forces, very, very weak intermolecular attractive forces. There are three types of intermolecular attractive forces. First one is hydrogen bonds. Next one is van der Waals forces. And we have dipole-dipole attractions. Dipole-dipole. Hydrogen bonds are the strongest. I'll draw 3 stars for that. Hydrogen bonds are strong. Dipole-dipole attractions come next to. I'll draw 2 stars. Or is 5 stars for hydrogen bonds, 3 stars for dipole-dipole attractions. Van der Waals force just 1 star. The stars show the relative strength of these bonds. Now, first point says they are highly volatile liquids. Why are they volatile? There should be very weak intermolecular attractive forces. They are van der Waals forces and dipole attractions. You see, carbonyl compounds form permanent dipoles. There are permanent dipole attractions. That means dipole-dipole attractions. They can form permanent dipole. What's the meaning of permanent dipole? The dipoles are there in the molecule always. Permanent dipole. They are permanently available. Carbonyl compounds form permanent dipole attractions and van der Waals attractive forces between molecules. They are weak attractions and can be broken at lower temperatures using less heat energy. Therefore, they are volatile. Probably this reasoning is asked in exam. Why aldehydes? Maybe aldehyde word is not given, but a compound is given, maybe propanol. Why propanol is highly volatile or boiling point is very low? This is the answer. And then we go to high water solubility. If a compound is able to make hydrogen bonds, then those compounds are, that compound is water soluble. Aldehydes and ketones can form hydrogen bonds. Water also can make hydrogen bonds. Hence, hydrogen bonds are formed between carbonyl compounds and water molecules. Hence, they are water soluble. Now, children, you can see in the first one, when I talk about highly volatile liquids, to explain that property, I said there are dipole-dipole attractions and van der Waals forces. But I didn't see hydrogen bonds. But in the second one, hydrogen bonds are there. It is because of this. You write a small note over here. Otherwise, you will not understand this later. Aldehydes and ketones cannot form hydrogen bonds with other aldehydes and ketones. With other aldehydes and ketones. However, aldehydes and ketones can form hydrogen bonds with another compound which can form hydrogen bonds. aldehydes, aldehydes, ketones, ketones, aldehydes, ketones. Aldehydes, water, ketones, water. Between aldehyde molecules, no hydrogen bonds. Between ketone molecules, no hydrogen bonds. Between aldehydes and ketones, no hydrogen bonds. But between aldehydes and water, there are hydrogen bonds. Between ketones and water also, there are hydrogen bonds. What is this idea? Aldehydes cannot make hydrogen bonds with aldehydes. Ketones cannot make hydrogen bonds with ketones. Aldehydes cannot form hydrogen bonds with ketone also, but both aldehydes and ketones can make hydrogen bonds with water molecules. So that's a summary. And over here, hydrogen bond formation between water molecules and aldehydes given. I think rather than having this to be observed, I think it's better if I draw hydrogen bond formation between maybe, what's the compound given here in our tute? This is some aldehyde, ketone, maybe a ketone. So I'll write how aldehydes and ketones can form hydrogen bonds with water molecule. To draw it, first I will draw the water molecule, OH, H. And an aldehyde or ketone molecule, probably ketone molecule. This is a ketone. This is R, I'll write 1. This is R, I'll write 2. The oxygen atom over here contains 2 lone pairs of electrons. In addition, in this carbonyl functional area, this oxygen is delta negative. This carbon is delta positive. Similarly, in this water molecule also, oxygen has delta negative for the delta positive of this hydrogen. And the other hydrogen also having delta positive, it also gives a negative charge to oxygen atom in water molecule. Now, when this delta positive hydrogen comes closer to delta negatively charged oxygen atom, because there are lone pairs of electron on oxygen, with the help of the lone pairs of electron, an attractive force is formed. This attractive force is called hydrogen bonds. Now don't think about the structure I have given here. On the side of this, we can take down this water molecule and carbonyl compound making hydrogen bonds. This is water molecule. This is a carbonyl compound. Carbonyl compound. If you draw this structure clearly, you get 3 marks for this. You get 3 marks for drawing this accurately, so do it now. I think this is how we can explain why an aldehyde or a ketone molecule is going to be water soluble, highly water soluble. It's given over here. They are highly water soluble. Will be the note. Aldehydes and ketones can form hydrogen bonds. Water also makes hydrogen bonds. Hence, hydrogen bonds are formed between carbonyl compounds and water molecules. Hence, they are water soluble. I think this is a clear idea to explain one of the two of the most important properties of aldehydes and ketones. One is highly volatile liquid. The other one is water soluble.